Assalamualaikum warahmatullahi wabarakatuh. We are from Group A when present about the force vector. Alright. Okay, before I start, I will introduce myself and my group members. Alright. My name is Muhammad Farhan bin SYUKUR and I'm from class DM3A. My metric number is 14DEM19F1005.
Good morning, sir. I'm Jemimah Kayelvili and my metric number is 14-19F1001.
Assalamualaikum. My name is Muhammad FARHAT bin ADLEE. My matrix number is 14DEM19F1011.
Assalamualaikum. My name is Muhammad AIMI DANIAL bin Muhammad SAIK and my matrix card number is 14DEM19F1009. Thank you.
Okay, we start from objective. Okay, first, to experimentally verify the triangle construction of parallelogram law of vector addition by using force table. Okay, second, to understand the basic concept of force vector. The third, to draw the force vector diagram, and the last one is to find and analyze the resultant force and direction from force vector diagram.
Assalamualaikum. My name is Muhammad Farhat bin ADLEE. My matrix number is 14DEM19F1011. So now it's my turn to tell about introduction. So the study of motion will involve the introduction of variety of quantities that are used to describe the physical world. Example of such quantities include distance, displacement, speed, velocity, acceleration, force, mass, momentum, energy, work, power, and etc. So we can see that this experiment is more focused on physics. The example that I tell is widely used in this experiment. So next, as not to waste time, I will go to the next introduction for vector quantities. So vector quantities. Vector quantities are often represented by scale vector diagram. Vector diagram depict a vector by use of an arrow drawn to scale in a specific direction. So vector diagram were introduced and used in earlier units to depict the force acting upon an object. So after doing this experiment, you will better understand in depth about vector. So next we will discuss about equipment. So first equipment is force table. So what is function for force table? So the force table is a simple tool for demonstrating Newton's first law and the vector nature of force. This based on the principle of equilibrium. So this force table is the main character in conducting this experiment. All results can be seen then based on this force table. So next is pulley. So a pulley is a wheel on axle or shaft that is designed to support movement and change of direction of a taut cable or belt, or transfer of power between the shaft and cable or belt. Other than that is hanger. So there are many other experiments in other fields where a variable hanging a mass. So this is a not shape hanger, but this is hanger in measuring weight. This similarity between these two hangers we can see to the shape of the hook. Next is weight. Slotted weight are used in student lab to teach physics. The slotted weight combination allows a student to quickly create any desired amount of mass. Next is string. So basically string does not mean the swing thread, but the string in doing this experiment. So string also can be found by studying the relationship between the tension frequency, length of the string. Next is ring. The purpose of this apparatus is to allow students to test mathematical calculation of equilibrium of force using rings attached to string. A center ring which at equilibrium is centered around the center post at force table. Last but not least is protector. So what is function for protector? A protector is a measuring instrument typically made of transparent plastic or metal for measure angles. Most protector measure angles in degrees. Radian scale protector measure angle in radian.
Hi, Assalamualaikum. I'm AIMI Daniel. My matrix card number is 14DEM 19F1009. So right now I'm gonna proceed to procedure and result. So the procedure, the first one is set up the apparatus and material as shown in figure 1 below. As you can see, this is the figure 1. It's already been set up. The apparatus and the material, the post table and the wave. So the second one is hanging the right wave for each angle given. So on our post table, we have to hang our specific wave on the specific each angle of the force that we had. So number 3 is record the data at the result table below. They will be in the result table that I will show you later. This record the data we from the experiment or the information we record on the result table. So number 4 is calculate all the forces acting on X and Y axis. So from the result table that we gather, we can calculate the forces acting on Y and X axis, X and Y axis. Okay. So moving on to the fifth one, the number 5 is repeat the experiment with data given on table 2. So on the experiment, we do 2 times of the experiment, table 1 and table 2. Both tables they have different angle and different mass of the material, mass of the wave. Yeah. So the assumption of the experiment, the first one is the pulley are frictionless. The second, the strings are very thin so that the direction can be marked out accurately. The third one is mass of the string is negligible. So as you can see here, this is our direction of our force 1, force 2 and force 3. This is what it looks like on the force table. So we're moving on to the result. So we got 2, table 1 and table 2. So the result for table 1, first experiment, force 1, force 2 and force 3. Force 1, the mass of force 1 is 100 gram. The mass of force 2 is 95 gram and mass for force 3 is 80 gram. And the weight force for force 1 is 100 over 1000. We have to convert it into kilogram because we want to convert in Newton, times the gravity 9.81, and we got 0.981 Newton. Also goes to force 2, 95 over 1000 times the gravity, we got 0.932 Newton. And the force 3, 80 over 1000 times the gravity, we got 0.7848 Newton. And for the angle, force 1 is 112 degree, the force 2 is 244 degree, and the force 3 is 0 degree. The angle for table 1 is clockwise. So on table 2, force 1, force 2 and force 3, the mass are all the same, 110 gram. And also same, if when we convert it to Newton. For the same 110 over 1000 times the gravity, we got 1.08 Newton. For the same for the force 1, force 2 and force 3, but the angle are different. For force 1, 239 degree, for force 2 is 121 degree, and force 3 is 0 degree. So for table 2, all the angulation is counterclockwise. From the information that we gather from this result, we can do the calculation based on the result that we have. Thank you.
So now I will explain about the data analysis and the discussion. This is the data analysis for the table 3. So before that, I will show how to find the force 1, force 2 and force 3. So for the force 1, it has 100 gram, which is we need to convert to kilogram. So 100 divided by 1000, you will get 0.1 kilogram, then times with 9.81, so we'll get 0.98 Newton. Then for the force 2, it is 95 grams, so divided by 1000, you will get 0.095 kilogram, then times with 9.81, you will get 0.93 Newton. So for the force 1x is 0.98 sin 22, you will get negative 0.37 Newton. For the force 2x is 0.93 cos 64 equals to negative 0.41 Newton. And for the force 1y is 0.98 cos 22 equals to 0.91 Newton. And for the force 2, 0.93 sin 64 equals to negative 0.84 Newton. So for the force 3, we need to find negative bracket. Inside the bracket, we need to insert the number of the calculation of force 1 plus force 2. So for the, I separate the force 1 and force 2x here, and the force 1, force 2y here. So negative 0.37 minus negative 0.41, you will get negative 0.78. Then positive 0.91 minus 0.84, negative 0.84, you will get the 0.07. So this is the value. Then I use this value to calculate this. So 0.78 square plus 0.07 square, you will get 0.6133. Then you have to use the square root in the calculator, so you will get the answer of 0.78 Newton. Then for the direction, I use is the tangent y equals to x. So the y value is 0.07 and the x value is 0.78. So we'll get 5.13. So for the table 3, for the forces, this is the force 1, force 2 and this is force 3. The direction is 22, 64, 5.13, because we already find over here. And this is for the F1x is negative 0.37, negative 0.41 Newton, and this is 0.78 Newton. So for the total, after we calculate the three values, this we will get the 0. Then for the force y is the 0.91, negative 0.84, then 0.07 Newton. So after we calculate, the total is the 0.14. I will talk about the data analysis of table 4. So for the table 4, we need to find the direction, magnitude force, then the y-axis and the magnitude force of the x-axis and the y-axis. So before that, for the force 1, it has 110 gram, which is we need to convert to kilogram. So divide by 1000, we'll get 0.11 kilogram times 9.81, so we'll get 1.08 Newton. So the force 2 also has the same value. So is the final answer also the same. Then for the force 1, x is 1.08 cos 59 equals to negative 0.56 Newton. And the force 2x is the 1.08 sin 31 equals to negative 0.56 Newton. Then force 1 y is 1.08 sin 59 equals to negative 0.93 Newton. and for the force 2y is the 1.08 cos 31 equals to 0.93 Newton. So for the force 3, we need to separate all the force 1, force 2 x-axis over here, then force 1 and force 2 y-axis over here. So negative 0.56 minus negative 0.56 equals to negative 1.12. Then negative 0.93 plus 0.93 equals to 0. So this is the value. Then for this 1.12 square plus 0 square, you will get 1.2544. Then you have to use the square root to find. So the final answer is the 1.12 Newton. So for the direction is tan y per x. So the y value is here and the x value over here. So 0 per 1.12 shift tan, you will get the 0 degree. So this is the value over here. So for the F1, F2, F3, this is the direction 59, 31, 0. Then this is the magnitude force of Fx, which is for the force 1 is the negative 0.56 Newton, negative 0.56 Newton, then 1.12 Newton. So after we total up, you will get the 0 Newton. Then for this here is negative 0.93 Newton, 0.93 Newton, 0 Newtons. After we total up, you will get the 0 Newton. Now I will talk about the discussion of table 1. So this is the diagram. So as you can see here, this is the force 1, this is the force 2, which is 0.93 Newton, this is the force 1, which is 0.98 Newton, then this is the resultant force. So the over here is 22 degree, here is here 22 degree, here 68 degree, here is 64 degree. So we need to find the alpha over here and the theta. So to find this value, we need to 68 plus 64, you will get 132. So the value over here is the same with the value over here is the same with the value over here. So here is 132, means here also 132. Then to find this value, we need to 360 minus 132 minus 132, you will get 96. Then 96 divided by 2 will get 48. So over here is 48 and here also 48. Then I draw the diagram. So here is the force 1, this is the force 2, and this is the resultant force. Now we have to find the alpha. So first we need to find the resultant force. To find the resultant force, I use cosine law formula. So 0.98 square plus 0.93 square minus 2 times with 0.98 times 0.93 cos 48, we will get 0.606. Then you have to use the square root, so you will get the 0.78 Newton. Then I use sine law formula to find the alpha value. So the A is the 0.78 and the sine A is sine for 8. Then the B is 0.98 and the sine B is sine alpha. So to find sine alpha, we need to 0.98 times with the sine 48, then over 0.78. So you will get 0.933. So to find the alpha, we need to shift sign. So you will get 0.933. You will get 68.91 Newton. So to find the direction, we have the alpha value and we have the 64. So it's easy to find the direction, which is we need to 64 minus 68.91. You will get negative 0.91 degree. Now I'm going to explain the discussion for table 2. So this is the diagram look like. Okay, this is the force 1, which is 1.08 Newton, and this is the force 2, which is 1.08 Newton. So this is the resultant force. To find the angle over here, we need to plus these two angles. So 59 plus 59, you will get 118. So here is 118. To find the angle over here, we need to 360 minus 118 minus 118, you will get 124, then divide by 2, you will get 62. So here is the 62 and here is the 62. Then I draw this the one diagram over here, which is this is the FR resultant force, this is the force 1 and this is the force 2. Then I use sine law to find the resultant force. So for the A, I put the 1.08, then over sine 59, then a resultant force over sine 62. To find the resultant force, 1.08 times with the sine 62 over sine 59. So we'll get the 1.11 Newton. So this is all about the data analysis and discussion.
Okay, it's turn me back to talk about the conclusion. Alright, in conclusion, from this experiment, I learned how to do the triangle construction or parallelogram, law of vector addition by using force table. Understand the basic concept of force vector. Then I learned how to draw the force vector diagram and to find and analyze the resultant force and direction from force vector diagram. We demonstrate the process of the addition of several vectors to form a resultant vector experimentally and graphically. By using this method, I able to see how each method produce a slightly different resultant force and resultant direction in degree. Okay, after that, the magnitude and direction of the resultant of several force acting on an object was successfully determined using graphical addition method. It was also proven using a force table. That's the resultant or net force acting on an object at equilibrium is 0. In my opinion, from this experiment, it's gathered a lot of knowledge about force vector. This experiment is really helpful for me and my group team to improve conclusion method about force vector. Alright, last but not least, I want to talk about the reference, how I get all the information. Okay, first I get the information from Wikipedia, second hub page, and third from engineering mechanic books, and the last one from engineering mechanics practice books. Alright, that's all from me and our group. Thank you for watching and enjoy. Alright, that's all. Bye bye.